Today we're going to talk about the domain and range of functions. Remember, today in class we stated that the domain is all the possible x values that could make up a function, and your range is all the possible y values that could make up a function. And today in class we talked about a strategy where we drew a box around our function, and then we looked at the left and right side of our box to figure out what our domain was, and these were the boundaries of our domain. So we can see here that the left side goes through -4, and the right side of our box goes through 6. And so our domain is all the x values that are in between -4 and 6, and this is the notation we use. And then we did the same thing with our range, except instead of looking at the left and right side of the box, we looked at the top and the bottom of our box. So the bottom, which would be the lowest values of our box here, go through -3, and the highest values of our box up here are the top of the box, go through 2. And the only thing about this notation is, remember, these are our y values. So all of our y values are in between -3 and +2. Well, today, this afternoon, we're going to talk about what if we have something a little different about our line. What if instead of having 2 endpoints, one of the sides of our box just goes on and on forever using this arrow? How does that impact this strategy, and how does it impact how we make notations about our domain and range? So in this case, if you notice that we make our box, the line goes outside of our box. It doesn't stop at the sides or the top of the box. It's like these aren't our boundaries anymore. We're still going to use this idea, though, with our domain. Okay, we can see that our left side is still going to end here at -4, so that will still be our left boundary. The difference is our right boundary. You'll notice I drew a dotted line here because it doesn't stop at this boundary of 6 anymore. It keeps going, and it's going to go, the arrow means it's going to go on and on forever. So it's actually going to go all the way up to +infinity. So when we write this domain, the lower boundary of our domain is -4, but the upper boundary is going to be +infinity, and it's going to be all of the x values that are in between those two amounts. The same thing can be done with our range. Okay? If we look at our range, we can see the bottom of our range is right down here. It stops at this endpoint. So our bottom boundary, our lower boundary, is going to be -3. But again, it doesn't stop at the top of our box. It kind of breaks through it with this arrow. So it's going up and up and up and up. It's going to continue in the positive direction all the way up to +infinity. So remember, these are all the y values in between -3 and +infinity. Okay, and this idea will work for any line. Okay, so this line has arrows on both sides. Okay, if I draw this box, we want to think about it. When we look at our domain, we don't have a boundary on either side now, because this left side is going to continue on and on forever, and the right side is going to continue on and on forever. So again, this left side, if we follow our line, it's going to continue on and on and on and on forever to infinity, but we're on the negative side of our numbers. So this is actually going to continue to -infinity. And on the right side, we're going to continue to +infinity. So it's weird, but the way we would write our domain is we're going to go from -infinity to +infinity and all of the x values in between. Now the same thing is going to happen with our range values. Okay, this is a little tricky though. Okay, so if you look at the range is our up and down values. So this, because it's above that x-axis, this is actually going to continue to +infinity over here because it's above our x-axis. Our -infinity is going to be down here because we're going down below the x-axis. Now when we write this, the -infinity still comes first because it's the lowest value. It's going to go from -infinity all the way to +infinity. Okay, and this infinity notation just takes a little getting used to. So let's look at another shape. This shape is a totally different shape. Okay, and we're going to draw a box on it. Okay, what I want you to notice about this box, hopefully you'll see this. The bottom of the box, it ends right here. Okay, it doesn't go beyond the bottom of the box, and that's great. But if you look at the left side, the right side, and the top of the box, these arrows are breaking through that box, which means when we talk about the left side, the right side, and the top, we're going to have that infinity notation. So let's take it one step at a time here. Let's talk about domain first. The domain is the left side and the right side. And if we notice the left side and the right side, we can see those arrows kind of breaking through, and they're going to go on and on forever. So this is going to go on and on and on towards negative infinity because it's on the left side where all our negative numbers are. This is going to go to positive infinity because it's on the right side of our y-axis, so the positive numbers. So we go from negative infinity to positive infinity and all of the x values in between. Now, when we talk about our range, it's nice because we have a limit on the bottom. Okay, the bottom limit we can see very clearly. It's going to go right through -7. So -7 is our lowest y value. Now, our highest y values you can see up here. Again, we're going to continue up above our x-axis. So both of these are going to continue going on and on and on until positive infinity. So our y values go from -7 to positive infinity and every y value in between. All right, one more situation and then you're ready to be on your own. Okay, this one is going to be a little bit different because we got a bunch of different lines here. So I want you to think about, we're going to think about our domain first. Okay, our domain is going to be our, oops, that's me change colors here. Our domain is going to be our x value. So we want to find the furthest to the left we are and the furthest to the right we are. Now what do you notice about on the right there? Hopefully you notice on the right that we have an arrow, so it's going to break through this line. It's going to keep going on and on towards infinity on the right side. But on the left side, we have a definite ending point right here at -3. So my domain values would be -3 to positive infinity and all the x values in between. Now let's take a minute and look at range. Now range on this one is tricky because we have a couple different points. We have this point here. Okay, we have this point here. We have this point here. But what do you notice about this arrow right here? Okay, the arrow, if I were to continue this arrow, eventually it's going to keep going. And it's actually going to break through the line that we have here. Okay, so this arrow, even though it's not as high as the top of the box that we would have drawn, this arrow is telling me that this is going to keep going on and on and on forever in the positive direction all the way to infinity. It's going to go past 4. It's going to keep going. So this dot, this top dot, is not one that we're worried about. Okay, our bottom boundary down here, that's a definite boundary. So it's going to go from -2 all the way up to positive infinity and all of the y values in between. Now we're going to practice this tomorrow in class. So if it didn't make sense, don't worry about it. Do your best shot on your own problems. Use your strategies. Give it your best try. And we'll talk tomorrow in class.